Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our previous video tutorial, we made use of the Landsat datasets, Landsat 5, 7, 8 and 9 to create three indexes. The first one that we created or calculated was the normalized differential vegetation index, the NDVI, then the normalized difference build-up index, the NDBI, and then subtracting the two, we generate the built-up index. And we created them and we compared them between the different Landsat data sets. We visualized them and so forth and so forth. So in this video tutorial, we're going to create additional indexes. We're going to create 3 additional indexes, and then we're going to see how they correlate with one another. So we're going to generate a cross correlation between any 2 pairs of those indexes, and we're going to create a scatter plot. Okay, so let's start. So we go to our trusted Earth engine, and from our Earth engine we go to platform and we go to our code editor. We open our code editor, and then you basically go to the scripts column and you scroll till you find your save project or your save script. In my case, it's called Daytime Tutorial 6, the one that we're gonna present for this video tutorial. Okay, so I load my different shape files or vector files. Now I have, because of the sizes of these scripts, I've decided to decrease my region of interest from the previous regions of interest, which were quite big, to just one specific part of that region of interest. So rather than looking at the West Coast district as a whole, I'm only going to look at one municipal area in that West Coast district, which is called Burke River. Okay, so I'm going to create that as my region of interest. I've still loaded the district as a region of interest, call it Roy D for district, and then also remember I also load that file with the 200 random points, which I called Roy location, which is the 200. Okay, then we load our map, our layers, we center it, we zoom it in, we create our clipping function. Then, as per the Landsat datasets landing pages within the Earth engine, we create our scaling factors. So this is scaling factor for 5 or 7, 8 or 9. And then we upload our different Landsat datasets. So that's Landsat 5, which is the unique identifier clip. I specify my time, and again I use the same time period that I used in the previous video tutorials, which is the entire time span of that data set, that Landsat 5 data set. Obviously you can change the dates, that's up to you. Ideal world, you don't want any crossovers or time periods where they cross over, just to make sure that you get unique images, but let's keep it for now. Then we apply the scale, and obviously this is an image, so there I think could be 700, 800 thereabout images for my region of interest. So I take that 700 or 800 images and I generate a median image. Okay, remember again, we went through other video tutorials where medium seems to be the preferred or the more efficient solution or statistic. So I use that, so I generate then a single image from this, all the Landscan images over this period, and I call it Landsat 5 image. Remember, these variable names are up to your discretion. Do the same for 7, do the same for 8, and the same for 9. Okay, now the first thing that we have to do is that we must remember that the bands in 5 and 7 are similar, whereas the bands in 8 are similar, but they're not similar to 5 and 7. And remember, band 5 and 7 doesn't have a aerosol band, where band 8 and 9 has an aerosol band, and I call it band 1. Okay, so therefore in 8 and 9 the normal true color bands starts from 2, whereas the true color bands in 5 and 7 starts from 1. So we have to make, so when you want to compare these four Landsat data sets, we need to harmonize or align the data set, the bands. So that's important, otherwise you're gonna not have images that you can pair with one another, because they will not be true color to true color, for example. So what I do, I create a new variable which is called Landsat bands. Okay, and these are the Landsat bands that I want to have in my analysis. I want a blue Landsat band, I want a green Landsat band, I want a red, I want a near infrared, I want a shortwave infrared 1 and a shortwave infrared 2. Those are the bands that I want to use. Okay, now that's the standard bands. There's a couple more that you can add, but I wouldn't go that far. I would stick with this bands. If you do supervised or unsupervised classification or any of these other type of things, that is the 7 bands or the 6 bands that you will use. You won't use other bands, so stick with those bands. So then I go into, then I generate my Landsat 5 bands, which is 1, 2, 3, 4, 5 and 7. And I generate my Landsat 7 bands. Remember, these bands come from the landing page. Okay, so they come from the landing page. To make sure, we go to Google, go to Landsat, you go to dataset, sorry, you go to Landsat. Let's go to Landsat 5. And remember, we worked with surface reflectance and tier 1. And you'll see there's the bands. Band 1, 2, 3, 4, 5 and 7. So that's the bands that I've created there. And now you see Landsat 8 and 9 starts with Landsat with bands 2, and it includes a band 6. So it doesn't jump from 5 to 7, 5, 6 and 7. Okay, so basically what I'm doing now is I'm saying to the Earth engine, in Landsat 5, band B1 is blue. In Landsat 7, B1 is blue. In Landsat 8, B2 is blue. In Landsat 9, B2 is blue, etc., etc. So basically, in my work or in my analysis going forward, I'm not going to use the bands B1, B2, B5, etc., etc. I'm not going to use those band references. I'm going to use these band references. So when I pull up the blue band, Earth Angel will know that the blue band is B1 and B1 in Landsat 5 and 7, and B2 and B2 in Landsat 8 and 9. So I don't have to continuously change between the bands. I just basically say blue, and then Google Earth will know I'm talking about those bands. So for example, in my indexes, if I have to call up the near infrared, if I didn't call it or rename it in the colors, then every time I had to remember to change from 4 to 5, from 4 to 5. And you may sometimes, no fault of your own, forget to change it, and therefore it won't be correct. So rather just create one set of harmonized band names, and then it doesn't matter whether you work with 5 or 9, the names will not make a difference. So there I'm telling the Earth engine, please rename the bands. Okay, so we have now a variable which is called rename bands, and that rename bands is these image bands which we have here, and they have renamed it to the Landsat bands. Okay, so remember, this input is these different individual bands. Okay, so in our case the input is these 4 data sets with their unique band numbers, and I'm renaming those numbers to that harmonized band stuff. Now obviously you can call these things 1, 2, 3, 4, 5, that's up to you, but remember, in our indexes we're looking for specific colors or variables that band names that we're going to include. Okay, so now I've got my harmonized band set. I've got my individual band sets, and I have now harmonized the individual band sets to my common band sets, band names. Okay, and it's called rename bands. Okay, now I've created 4 variables. Okay, and I've given them exactly the same name, so I don't have to further down continuously change the inputs into my calculations. I can simply just change the inputs here. So I've got a Landsat variable, which is Landsat 5. Then I've got a Landsat LNS, a Landsat variable, which is Landsat 7, a Landsat variable, which is Landsat 8, and a Landsat, which is Landsat 9, which is basically the renamed brands. Okay, remember there's the Landsat 5 image, and I'm rebranding that Landsat 5 bands, and I'm rebranding it with that variable. So now this variable here, Landsat, the normal Landsat will be the Landsat dataset, but with these bands, not with those bands, because it's renamed. So here that you see I've got 4 identical variables, depending which one I want to use. So if I want to work with the Landsat 9 dataset, then I disable Landsat 5, 7, and 8, and I just enable this particular one. So all the calculations down will now use the Landsat 9 dataset. If I don't want to use Landsat 9, I just, what did I do now? Let's just quickly redo that. That's Landsat 9 and Landsat 9. So I don't want to work with Landsat 9. I would prefer to work with, let's say, Landsat 5. So I just activate by deleting the 2 forward slashes. I'm now activating that particular Landsat specification, and all my calculations will now use Landsat 5. If I don't want to use Landsat 5, I deactivate it by including the forwards, and that's how, let's say I want to work with Landsat 7, I simply just delete the 2 forward slashes, and now all my calculations will be based on Landsat 7. It just simplifies it, then you don't have to duplicate and triplicate and so forth the script. You just change the variable details on top, and it will then basically use that specific data set. It just makes the script shorter, and it makes it less tedious in terms of generating the images and so forth. Okay, then I've got a harmonized visualization parameter. You can see it is the true color visualization, red, green, and blue. Remember, if I didn't rename the bands to the colors, I would then have band 4, band 3, and band 2 for Landsat 8 and 9, and band set 3, 2, and 1 for Landsat 5 and 7. So to give you a good example, then I would have had to use 2 Landsat visualizations, one for Landsat 5 and 7 and one for Landsat 8 and 9. Now, because the bands are all harmonized, I only have to use one visualization parameter, 3 red, green, and blue. So it will automatically refers to bands 3 and 2, 3 for Landsat 5 and 7, and band 4 for Landsat 8 and 9. Okay, so that's where the beauty of renaming the bands or harmonizing the Landsat bands comes into. Okay, then I'm displaying it. You see again, I'm displaying LNS. Now, which LNS or which variable am I displaying? It depends which one I've made active. You see, I only gonna I don't have to have 4 codes now for each Landsat. I only have 1 code, and that will display, or 1 variable, and that will depend on which one I activate. So if, in this case, it will display Landsat 7. If I deactivate Landsat 7 by including that, and I activate Landsat 8, now it will display Landsat 8. Okay, and you'll see now I don't have to change the vis, because the vis is harmonized as well, because it's got the same one. I don't have to have a Landsat vis for 5 and 7 and so forth and so forth. Okay, Now I've created my visualization parameters for my different indexes. Remember, I've got the normalized difference vegetation index visualization parameter, which is, remember, these indexes is most of them are between -1 and 1. Okay, that's just the way normalization works. It's by normalizing, you basically force the values to lie between -1 and 1. And the color scheme, where do I get the color scheme? You can either go to your layers, go to the nut there, click on it, get the different colors in terms of its codes, or you can actually go to any of these parameters, like for example, so add a marker, and you can go there, click on the nut there, and you can choose colors. You see, if I choose purple, that will be the code. If I choose that blue, that will be the code. So you can simply just generate those codes from this as well. Let me just delete that. Okay, so there's different places or different methods of generating those color palette or palettes. Okay, there's my normalized difference vegetation index, my normalized difference build-up index, my build-up index, my normalized build-up index, which is a different variation, normalized build-up area index, normalized area, I can't remember the name now, I figure that one out now. Anyway, so remember previous video, we've calculated the NDVI, the NDBI, and the BUI. We've calculated those three indexes. Now we've calculated three more, which is the NBUI, the NBUIE, and the BAEI. There's three different indexes. I will leave a link to an article that explains these indexes. Okay, so if you're not sure what they mean or are meant to mean, and the theory behind them, I will leave the description of the link of the article in the link below, so you can just go and consult with that specific article. Okay, so there I've got 1, 2, 3, 4, 5, 6 indexes. Okay, and there's the formulas for them. So the NDVI, okay, I select, you see, now I don't have to worry about the band numbers here, which is near infrared is band 4 in 5 and 7. You have Landsat 5 and 7, and it is 5 in 7 and 8 and 9. So I don't have to change it. One code for one thing. Okay, remember the brackets, the use of the brackets, exactly the same as you would do normal algebra. Okay, so I've got the near infrared, which I'm going to subtract from the red, and then I'm going to divide that value with the near infrared plus the red. Okay, now I've put that whole formula in brackets because when that value is calculated, I want to name that calculation NDVI. Okay, that's just what this part of the code means, is that the value that's created here, the variable is called NDVI, but it will have a different band. Now what I want to make sure is that that band that I calculate there is also called NDVI, because what it will generally do, if I don't do that, it will name this band the first band in my calculation. So this is quite a neat trick to remember, okay, is to make sure that I rename my calculated band the same as my well, you can use it, you can call it whatever you want to call it. I just call it the same thing. Okay, so yeah, just remember, if I didn't have this, then the band name for the NDVI will be NIR. Okay, and I don't want that. I want the band name to be similar to the variable name, and therefore I rename it. But just remember the brackets. Okay, so there's the NDBI, which is the shortwave infrared minus the near infrared, divide by the short infrared plus the near infrared. I get so in this case the band name will be shortwave infrared 1. Okay, which I don't want because I've got more than one I would have more than one of those band names. So I rename it NDVI. And then I take the two, the NDVI, and I subtract the NDVI, and I get the built-up index. Okay, so that's why I've got that value. So in this case, that BUI, the built-up index, band name would have been NDVI, which will be confusing. So I rename it built-up index. My built-up new built-up index. Okay, there's its formula there. And then you've got the NBUAI. Now that's quite a long calculation. For simplicity, I've calculated in two parts. I've got the denominator calculated there, and then I've got the denominator calculated there, and then I divide the denominator by the numerator. Okay, so there's my denominator and there's the numerator. So to calculate this, I take my denominator, which I've variable that way, and I divide it by my numerator, which I variable name that. Okay, so I divide the two and I call it NBUAE. Now you'll see there that this one you first have to divide and then you subtract. Where the previous ones you first subtract and then divide, here you first divide and then you subtract. So that's where you see there's the subtract and then you divide. So you take this value and you subtract that by, and that's why that bracket is there, you subtract it by the short wave divide by the green. And you'll see in the article the formula. And there's the BUIE, which is the red. You add a value of constant value of 0.3, and then you divide it by the green and the short infrared, and I rename it. So there's my script or my expressions, my mathematical expressions to calculate each of these indexes, and then I rename the bands to match the variable name or the index name. Okay, and you see the beauty of having harmonized band names is that I don't have to worry about whether I'm working with 5, 7, Landsat 5, 7, etc. And then I'm going to add it to my layer. All of these indexes I'm going to add to my layer. Okay, there they sit, all of them sitting there. And then now this is where, okay, so this is fairly straightforward stuff so far, what we've done so far. Okay, and then what I want to do now is I want to generate cross correlations by either calculating the R itself, the singular statistic, the correlation statistic between any two band indexes, and I want to display the cross correlation visually by a scatter plot with a trend line. Okay, so that's the two main things that I want to do now. I just want to take any band combinations and I want to generate a cross correlation statistics, and I want to generate a scatter plot with a trend line. Okay, so first I have to create the combinations. Okay, the x and the y variable, the x and the y, which two indexes I'm gonna display or calculate the cross correlation, how they correlate to one another. And so I've created again 4 combinations. My first combinations NDVI and NDBI. Then the second combination NDVI and BUI. Then a third combination BUI and NBUI. Then a fourth combination NBUI and NBUAI. And you can generate as many combinations as you want to. That's up to you. It's totally up to your discretion. Again, I call them exactly the same name because similar to the above, I can simply decide which one I want to work with by activating or deactivating the script. And then I print the combine just to make sure that I'm working with the correct indexes. So first I combine them. Okay, that's important. Now I'm going to generate, in this case, 2000 random points, because I can't generate the correlation for the entire region of interest. It's just not going to work. It's too many pixels. It's going to time out. It's going to not work. So I'm going to generate random points, and based on those random points, I'm going to calculate for that random points the cross correlation and the scatter plot. And you can change it to 1,000, 5,000, 20,000. That's up to you. Okay, so I'm going to scale it, meaning I'm going to generate my 2,000 or my random points, and I'm going to generate it within my region of interest. Okay, I'm going to accept the geometries, meaning the x and y coordinates of that specific random point. So here I'm creating random points because remember, the region of interest is too big just to do it for the whole region of interest. So I reduce my region of interest to 2,000 random points, and based on the 2,000 random points, I calculate the cross correlation and the scatter graph. Okay, then I'm going to add this combination, or I'm going to add the 2,000 random points, and this is what this is. I'm adding the 2,000 points. Remember, values is the variable, so I'm adding values to it, and that's just making it black and give it a name called sample. Okay, now then I'm going to add this to my chart. What I'm going to add, I'm going to add the values, which is this one here, the 2,000 points. The x property is in my case NDBI, and the y is, so I'm assuming the relationship goes from NDBI to NDBI, but that's up to you. You can change that causality yourself, but it doesn't really matter because you're looking at a singular variable, so whether it's this one or that one, x and y doesn't really matter. Okay, so yeah, so where do I get for the 2,000 points? On my x variable is NDBI, my y variable is NDBI. I'm going to do a scatter plot. The scatter plot will be in size 4, the color will be in red, although that's irrelevant, and my title, and here I'm adding a trend line. Okay, I'm adding a trend line to my scatter plot, and the scatter plot details are presented here, and in my scatter plot I've got NDBI as my x variable, NDBI as my y variable based on the 2,000 points. Okay, so I simply just then I'm going to print it, and it will give you your scatter plot. There it sits. And then I'm going to also, what I'm going to do further is I'm going to add all these bands or all these variables into one image or to one variable. Okay, and I'm gonna present that image as a layer, which is this one here. Okay, that you don't have to do. Just found it quite interesting. If you add all of them, you present it as a singular band, what will it look like? And then obviously I want to find the cross correlation between the bands. Okay, and in this case, which is the one that I want to so it's a correlation, it's the regress, it's reduce the region. Reducer is the Pearson's coefficient that I'm going to use, and I'm going to use it for my region of interest. And the variables, the band combinations that I'm going to use is my NDVI and NDBI, which is the same as this one here. The x and y, there's my x and y, and I just create again which one is which one, doesn't matter. So that's the stack that I'm going to work with, or the two bands that I'm going to work with is the NDVI and that, and I call it image regression. Again, that you call it, and that's what I'm going to calculate the Pearson's coefficient. My scale is 250. You can change the scale again. If you've got limitations on your timeout because it's too much, just keep on increasing the scale. And I'm going to print my correlation. Okay, so we've loaded our 4 images. We've created a single image for each of the data sets. We harmonized the bands, Then we've calculated all of our indexes, or we've put our equations in, and then I can calculate or display each combination for each Landsat data set in terms of its cross correlation via a scatter chart or a correlation statistic, Pearson correlation statistic. And you press run. Okay, now I've done it. And there is my scatter graph. Let's quickly make it a bit bigger. There's my scatter graph. Well, let's first go. Make sure the image, I've got two bands, the NDVI and NDVI. Okay. And there's my scatter graph. The NDVI, as I said, remember, it's on my NDVI is on my y-axis. And I've got NDVI on my x-axis. And as we said, there should be an inverse relationship because the one measures vegetation, the other one measures urban settlements. Now, one would assume that where there's urban settlements, there would be lower vegetation mass or health, and vice versa. That's why I assume an inverse relationship. And you can see those are 2,000 points. That's a 2,000 points. And there's my trend line. And you can obviously present it bigger, and you can download this into a CSV if you want to work with it in Excel. And there is my covariance. Let's open it. There's my covariance statistic. You see the minus. There's the inverse trend line, minus. And you see the value there, and it's -4, which is medium or fairly average correlation. So it's not a strong negative correlation. There is a correlation, but obviously it's not a strong negative correlation. Remember, that is now for which one did we activate? That is now for Landsat, let's say for Landsat 8. Okay. So if I want to see for Landsat, let's say for Landsat 9, I deactivate Landsat 8 and I activate Landsat 9. Just remember, the correlation is for Landsat 8 between the NDVI and the NDBI was -0.4, and there is the scatter graph. Okay, so all I have to do, I have to do nothing more. All I have to do is change the variable on top, and I press rerun, and it will recalculate all these things, and now I can compare. So we've rerun the code now, or the script, and we've activated Landsat 9. You can see it's activated, and we've rerun it, and you see that it's very similar, -0.40. So from Landsat 8 to Landsat 9, there seems to be very little difference between the two. But coming back to my but, you'll see that there's quite a bit of overlap between Landsat 8 and Landsat 9. So it's almost the same thing. So we actually should make, so let's rather use a Landsat 5, because see, this is where the issue of, so let's rather make it Landsat 5. Let's see if it will allow us now, Landsat 5, and let's run it and see what happens. It will generate. That's why it's so important to specify you can see -0.38. So it does seem like over the period, and we've just done it very intuitively, that over the period, the correlation between the NDVI and the NDBI has increased in strength. Still negative, so meaning where if there's the build-up areas have seen a worsening of land mass, and where there's a worsening of land mass, most probably there's an increase in build-up activities. And you can look for the layers, etc., etc. Okay, so that is generating all these indexes from the different Landsat data sets. Important stuff is to harmonize, 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 and then you just create one set of code, which makes life much easier. So thank you very much. Thanks for joining me on this fabulous journey. I really enjoy doing these videos, and I'm looking forward to making more of them and sharing it with you. And you're more than welcome to give me feedback, and please like and subscribe and do all the fancy things. And then Um, I'll see you on